Hello everyone, I'm physics teacher and welcome to my podcast where I attempt to teach high school physics and chemistry concepts to my daughter in elementary school. Say hi, Coins.
Hi. Hi.
Be sure to listen to the end to see how she does on her final quiz of 5 questions. If you enjoy it and want a second season, let us know. This is going to be episode 4, which is our first episode on chemistry, where we're going to learn about trends in the periodic table. All right, so Lynn, do you remember 2020, all the schools shut down and I homeschooled you for a while?
Yes.
Okay, I actually taught you Bohr Rutherford diagrams when I homeschooled you. Do you remember doing that?
Yeah, like that stuff.
Yeah, the stuff I made you draw, like all the little particles in the center and all the particles orbiting. Do you remember what all those particles are called?
No.
That's okay if you don't. It's been a few years.
I don't know. Electrons.
Okay,
and
yeah.
Something.
So we have electrons. Electrons orbit the center, and then there are 2 particles in the center. Do you remember what the center is called?
The center.
It has a special name.
I don't know.
It's called nucleus.
I don't remember that at all.
Okay, well, it is called the nucleus. All right, so in the nucleus, we have protons and neutrons.
Oh, yeah.
Okay, we are not going to focus on protons and neutrons today, but we are going to focus on those electrons. So electrons can exist in different orbits, and you can have multiple electrons existing in a certain orbit. For example, in the first orbit, you can have up to 2. Notice on the periodic table, let's look at the first row. How many elements do we have in the first row?
7.
The first row.
That's what it is. 7.
Ah, that's a column.
Oh. 2.
2. So we have hydrogen and helium. So interestingly enough, in our first orbit, we can only have 2 electrons. How many elements do you see in the second row? You can count if you like.
Okay, 1 second. So 2 and 6. 8.
8. So we can actually have 8 electrons in our second row. And in our third, how many?
8.
Another 8. Okay, so this is our first pattern in our periodic table. As you go down a row, for example, our first row, which starts with hydrogen, has 1 orbit, or 1 shell, we sometimes call it. The next one has 2 shells. The one that starts with lithium, the one that starts with sodium has 3 shells, potassium has 4 shells, and so on. Right? So if I were to pick any element here, take carbon, because it's in the second row, you automatically know how many shells or orbits does it have.
2.
2. Okay, so there's our first trend in the periodic table. Now I said you can fit a certain amount of electrons on to that outermost shell. Okay, so we can fit a certain number of electrons onto the outermost shell. So let's look at the second row. So we have lithium and then beryllium, boron, and so on. So they all have how many orbits?
2.
2. The first orbit is full. The second orbit, the one furthest from the center, we are going to place 1 electron on lithium, 2 electrons on beryllium, 3 electrons on boron. You starting to see a pattern?
No.
How many on carbon?
4.
4. Nitrogen?
5.
Oxygen?
6.
Fluorine?
7.
And neon.
8.
Good. All right, so that's our second pattern. So as we go from left to right in our columns, we add another electron onto that furthest or outermost orbit.
Okay.
So I should be able to look at any element on the periodic table and ask you how many orbits and how many electrons on the furthest ones. Let's try this.
Okay, I got this.
Take a look at aluminum. How many orbits does aluminum have?
3.
3. And how many electrons on the last orbit?
3.
Good. All right, so there's our first 2 patterns. Any questions so far?
No.
No? Okay. Are you enjoying chemistry?
Yes.
I know you've been looking forward to the chemistry episodes. Okay, next we are going to look at the size of these atoms. Okay, they have some sort of radius going from the center where the nucleus is all the way to the outermost orbit of electrons. Now there's a pattern for how big they are. Okay, now most people will look at the number in the top left corner. That's our atomic number. That number simply tells us how many protons are in the nucleus. Okay, protons have a positive charge. So if you looked at magnesium here, magnesium has 12 protons in the nucleus. Over here, sulfur has 16. So most people start to assume, well, if you have more protons, the atom must be bigger. But that's not actually true. Okay, there's something called the electromagnetic force. So have you learned in school that similar charges repel, but opposites attract?
Sure.
Okay. Have you ever tried like charging objects and get them to attract to each other or something?
Like magnets?
Okay, magnets. You've learned about magnets, right? North and south poles. Have you done that?
Yeah.
Okay, that's a sarcastic yeah, so that would be a no. Okay, if you had a North Pole and a North Pole, would they attract or repel?
Repel.
Okay, and a North and South?
Attract.
Okay, so it's the same thing with charges. It's actually the same basic force. It's called the electromagnetic force. So if you have a positive and a negative, they're opposites, so they attract. Right? Now, in a atom, we have a whole bunch of positive charges, our protons in the center, and then our electrons are negative charges that orbit. So protons and electrons would attract or repel. Opposite charges.
Attract.
Attract. Okay. Now, here's the big thing. The more protons you have and the more electrons they have, the stronger the attraction and the closer they're pulled together. So let's look at lithium. Lithium has 3 protons. And it will also have in a neutral atom the exact same number of electrons. So it's neutral because the number of positive charges is the same as the number of negative charges. So we've got 3 protons in the center, 3 electrons orbiting. It has a very, very small attraction compared to, if you look at oxygen, okay, oxygen has 8 protons, so 8 positive charges and 8 negative charges. It has way more charges, and so a much stronger force that actually pulls those electrons closer. So in an oxygen atom, the electrons on that outer orbit are pulled closer.
So it's smaller?
Yes, exactly. So an oxygen atom is actually smaller than a lithium atom. Now this is when we're looking at the same row. If we go down to sodium, we now add a 3rd orbit. So adding a 3rd orbit makes it smaller or bigger? Bigger.
Yeah.
Yeah, so like 1 orbit close and then further out your 2nd, further out your 3rd, right? And that's always going to take precedence, right? If we add another orbit, it'll always be bigger. So as we go down the periodic table, we get bigger atoms. So if you look over here at rubidium, is rubidium bigger or smaller than sodium?
Bigger.
However, when we go across, we actually get smaller because that force pulls it in closer. So look at magnesium and sulfur, which is bigger.
Magnesium.
There we go. So now we understand the patterns for the sizes of the actual atoms.
What if it's like sodium?
Yep.
And a xenon.
Xenon?
Yes.
Okay. So the vertical pattern will always be more important or have a bigger effect than our horizontal pattern. So xenons has a lot more orbits, right, than sodium, so it's bigger.
But it's like the furthest right, and that makes it smaller.
That would mean it would be smaller than, say, another atom in the same row, like rubidium. But it is bigger than any atom.
Above?
Exactly.
Okay.
Okay. Now, haven't mentioned this yet. We've been talking about rows and columns, but we do give rows and columns special names. Okay, all the rows, okay, are called periods. So this is the first period, the second period, the third period, and so on. And all the columns are either called groups or families. And that's because elements in a certain column behave similar. So for example, our first column or our first group, we actually give a special name called alkali metals. And alkali metals, I know I've had you put some alkali metals in water before.
I also know from a periodic table song.
Oh yeah, the periodic table song. They say alkali metals in it. Yep.
Yeah.
And they are all extremely reactive. And so they're all similar in that sense. Okay. Our second group, they're called alkaline earth metals. The ones all the way at the very end, that last group, are not reactive at all. They are called noble gases.
Because they're fancy.
They are. They're fancy. Okay. So these are all called atoms. Have you ever heard the term ion?
Sure.
Oh, okay. What's an ion?
Whatever you think it is.
Oh, yeah. Okay. There's no shame in saying no if you've never learned something, okay? That's why we're doing this, so I can teach you. An ion is simply an atom with a charge. So, let's look at lithium. Lithium has 3 protons and 3 electrons. So 3 positive charges and 3 negative charges. If I were to strip away one of those electrons, how many negative charges would it now have?
2.
2. And it has 3 positive. So those don't balance anymore. We have more positive than negative. So that atom now has an overall positive charge. So it's now called an ion. Okay? And it requires a certain amount of energy if you're going to strip an electron off of an atom. And there's a pattern with this, with how much energy is required. So this is called ionization energy, the energy required to turn an atom into an ion or to strip off an electron.
Can I guess how much you need?
Right now you're looking. You're looking at our periodic table, and this is a great periodic table. It's ptable.com, and it actually tells you, for example, hydrogen, the ionization energy. It gives you exact numbers, but we're not going to talk about numbers.
I wasn't looking at it a lot at all.
Okay, but we're going to look at the trend, whether or not it increases or decreases as we go up, down, right, left on the periodic table. We're not going to look at specific values. You can do the math when you get to high school. We're just going to go over concepts. Okay?
Yes.
Okay. So, now there are different ionization energies. There's the first ionization, the second ionization, and that's just, the first is the amount of energy it takes to rip off that first electron. The second is how much energy it takes to rip off the next electron, and so on. Let's just look at first ionization levels. Okay? Now, we've talked about that force pulling things together. So if you look at lithium, lithium has 3 protons and 3 electrons, and oxygen has 8. So which one has a stronger force pulling them together?
Oxygen.
Oxygen. There's a lot more charges, so it's a lot more pull. So if oxygen is more strongly holding everything together, do you think it would be easier or more difficult to rip something off of it?
Easier. Oh, harder.
It would be harder, wouldn't it? If someone's holding on to something extremely tightly, it's harder to rip it away from them, isn't it?
Unless you...
No. Okay. Okay, so therefore, the ionization energy will be higher for oxygen because it's harder to pull it off.
Yes.
Okay, so as we go to the right along a period or along a row, the ionization energy increases. What about if we go down? So let's stick in this one column. Let's compare lithium and potassium. Lithium has how many orbits?
2.
Potassium has how many orbits?
4.
Okay, so the electrons on the last orbit are much further away for potassium, right? Now, the further away you are, the less force there is pulling it together. So for potassium, it has 4 orbits. Those electrons are very far away compared to lithium, so they're not very strongly held to potassium. So do you think it would be harder or easier to pull an electron off potassium?
Easier.
Easier, yeah. There you go. So it's easier to pull it off potassium, so it requires less ionization energy.
Yeah, I can tell you the ionization energy.
Okay, what's the first ionization energy?
It's 418.8 kJ. kJ.
Slash
mole.
Okay, the kJ stands for kilojoules. Joules is a unit of energy. I'll teach you that in physics. And mole, the mole is a unit in chemistry we use to describe a certain amount. And that's going to be on our next lesson. We're going to talk about moles and stoichiometries.
I thought
Right?
it
Either
was...
on our next lesson or the one after that. We'll see. All right.
Time for our quiz?
Time for our quiz. Ready?
Yes.
All right. Take a look at magnesium. Magnesium has how many electron orbits? How many shells?
3.
3. All right. Good. All right. Good start. Next one. Let's look at carbon. How many electrons, not orbits, how many electrons does carbon have on the last or outermost orbit?
4.
Oh, we got this. Okay. Next, which atom is bigger, lithium or oxygen?
Lithium.
Okay, 3 for 3.
Yes.
Okay, you like chemistry better than physics, don't you? Okay, next, what is an ion?
It's like charged atom?
4 for 4.
Haha.
All right, next one. Lithium or potassium? Which one has a larger ionization energy? This is it. Can you get 5 out of 5? Lithium or potassium? Which one has a larger ionization? Which one requires more energy to strip off that
lithium?
5 out of 5. We got a clear, perfect 5-star score today. Good job. High five.
Know, right? High five.
All right. So that's the end of this episode. The next 2 will also be chemistry.
Yes.
Look forward to that, as I think she prefers chemistry over physics. All right. Thanks for listening.